Hello, thanks for joining us. In today's video, we will be going over Unit 1 Kinematics. Kinematics describes the motion of objects. Vectors have both magnitude and direction. Some examples of this is displacement, which is the change in position, velocity, which is the change in displacement over time, and acceleration, change in velocity over time. We will go in depth into all of this later. And then scalars only have magnitude. Examples of these are speed, which is the scalar version of velocity, and time and mass. So, position is the location of an object in space at a particular instant in time relative to a reference point or origin. Displacement is the change in x. It's the change in position. It's the straight line distance between an object's initial and final position. Displacement does not equal distance. Imagine position to be a point on a number line where the right direction is positive and the left is negative. Say we go from x equals 4 to x equals 7, and then x equals 7 to x equals 2. The distance traveled equals 8. However, the displacement equals negative 2 because we will have gone from x equals 4 to 2, so we have traveled left. Speed is scalar. It only tells you how fast you're going, while velocity tells you how fast and in what direction. The instantaneous velocity is the velocity at a specific time, while the average velocity is the velocity over a time period. The formula for average velocity is change in position over change in time, or displacement over time. For example, if you run 100 meters east in 20 seconds, your average velocity is 5 meters per second east. Acceleration is the rate of change of velocity in meters per second squared. The formula for acceleration is change in velocity over change in time. If your velocity increases from 2 meters per second to 6 meters per second in 2 seconds, your acceleration is therefore 2 meters per second squared. Positive acceleration means that you're speeding up in the positive direction, while negative acceleration, also called deacceleration, means either slowing down or speeding up in the negative direction. It depends on the context. So these are the uniformly accelerated motion equations that will be provided on your equations sheets. The variables we have here are position, initial position, which is denoted by x subscript 0, and then we also have velocity, initial velocity, acceleration, and time. Use these use these equations when you're solving problems with things that are speeding up, slowing down, or falling, but the acceleration must be constant or these equations do not work. Free fall. When objects fall near Earth, they accelerate at 9.8 meters per second squared downward. We call this g. So if you drop a ball, its velocity increases by 9.8 meters per second every second. Make sure to pick a positive direction. Usually upward would be positive and downwards is negative. And remember that acceleration due to gravity is negative if up is positive because objects fall down. Okay, so this is a practice problem. A ball is thrown straight up with a velocity of 15 meters per second. How high does it go? You can try it yourself, and then we'll go over it. Okay. So this is what we know. The initial velocity is 15 meters per second, and at the top, the velocity equals 0 meters per second, and the acceleration is negative 9.8 meters per second squared because that is g. And we are trying to find the displacement. So we will use this uniformly accelerated motion equation. You plug in the numbers, and then you get the ball traveled about 11.5 meters. You also have to be able to look at and interpret graphs. So these are a position time graph, velocity time graph, and acceleration time graph. The slope of a position versus time graph equals velocity because velocity equals displacement over time. Here, because it's not straight, if the tangent at a specific point would be the instantaneous velocity. The slope of a velocity time graph equals acceleration. The area under a velocity versus time graph equals displacement because because velocity times time is displacement, and the area under acceleration versus time graph equals the change in velocity. Take some time to read the problem and solve it for yourself before I explain. Okay, so the correct answer is C. To determine the vertical height reached by the ball, we focus only on the vertical component of the ball's motion. The ball has an initial vertical velocity of 20 sine 30 or 10 meters per second. The ball's final vertical velocity at the top of its path is 0 meters per second. Using kinematics equations, the maximum height of the ball can be determined. Moving on to the next question, you can pause and try this yourself as well. The correct answer is B. The displacement of the cars can be determined by looking at the area under the curve of the velocity time graph. The area under the curve for the red car at time t is vt, while the area under the curve for the blue car is also vt. So both cars have the same displacement. At time t, the blue car has the greater velocity of 2v compared with the red car's velocity of v. Therefore, B is the correct answer. Again, try this by yourself before we go for the answer. The answer is D. So here the acceleration is the change in velocity, and to do this you can do a vector subtraction as shown here to get D. Thank you for watching. Visit vikinginitiative.com for more resources. If you have more questions, you can join the group chat and ask our tutors. Thanks for watching.